Density lets us relate the amount of mass something has to its volume. Okay, so density is calculated as mass over volume. All right, and so when we look at this, we have some pretty typical units. You can see some on the slide, but typically when we look at density, we're looking at grams per milliliter or grams per centimeter cubed. Okay, interesting fact, 1 milliliter equals 1 centimeter cubed. They mean the same thing. So milliliters is a unit of volume. When we know the length, the width, and the height of something, we can calculate the volume. And so we have that equivalency between milliliters and centimeters cubed. So now we have something that we can go back and forth in between. So the vast majority of substances, we use grams per mil or grams per centimeter cubed. Another abbreviation for centimeter cubed is a cc, so that means centimeter cubed or milliliter. When we talk about gases, gases are not very dense at all. So gases, we're going to use similar units. Gases, we will use grams per liter, but for the vast majority of substances that we talk about, it'll be grams per mil. All right, so I've got some substances here. I've got some water, a cork, some ice, aluminum, a piece of lead that all have different densities. So water at room temperature has a density of approximately 1 gram per mil. Now, density is temperature dependent. If you look at tabulated data for density, you will see that it has to do with the temperature, but water rounds to 1 gram per mil. When I look at things like lead, lead has a density of 11.3 grams per mil, much more dense than water, which is why lead sinks in water. When I look at ice, ice's density is very similar to water. So ice is really unique. Most substances, their solid form is more dense than their liquid form. But with water, with H2O, the way water crystallizes, its solid form is surprisingly less dense than its liquid form. Now, it's not that much less dense. It's only 0.92 compared to 1, which is why this piece of ice, if you look at it, okay, a whole bunch of it's still below the surface of the water. It doesn't sink because it's still slightly less dense, but it doesn't completely float nearly as much as the cork does because its density is so close to that of water. This is why things like icebergs are so dangerous, because most of the ice exists underneath the water instead of above the water. Okay, so here's a really easy visual. Oh, my head cuts off some of this. So we've got vegetable oil, water, dish soap. This is corn syrup. And then this last one is honey. Okay, so looking at these, which one is the most dense? The one that's on the bottom. The honey is the most dense. Okay. A couple more visuals here. I have 2 cubes. Both these cubes have the same volume. According to the scales, 1 cube is heavier than the other, so which one's going to have the greater density? Well, the one that has the more mass per unit volume. So that's going to be the green cube. Okay, here I have 2 cubes that have the same mass there. 1 cube has a smaller volume than the other one, so which one has the greater density? That one with the smaller volume. Okay. All right, now let's practice a few things with density. Okay, so we've got some ebony. We've got a piece of ebony with a mass and a volume. So let's find the density of ebony. So again, it's just mass per unit volume. So I'll take my 522 grams over my 435 centimeters cubed. And the density of my ebony is going to be 1.2 grams per centimeter cubed. And then again, that 1 centimeter cube is the same as 1 milliliter. So I can also write this as 1.2 grams per milliliter. Same thing. Okay. All right. Next, we've got some gasoline that has a density. We have a volume. So what is the mass contained in this volume. So we can use density as a conversion factor, okay? So we have this density here. That means that I have 0.68 grams for every milliliter. So if I have 90.5 milliliters, I want milliliters to cancel. So I'm going to put 1 milliliter on the bottom and 0.68 grams on the top. Okay, and what I end up getting is 61.5. Now, density is a measured quantity, which means that when we use density as a conversion factor, it does affect our significant figures. So here I have 3 sig figs. Here I have 2 sig figs, okay, which means I have to cut it 2 sig figs. So I report my mass here is 62 grams. Okay. All right, now I've got a bottle with some cleaning solution in it. It fell, it broke, okay? So I know the mass of it, I know the density of it, so what volume do I have to clean up? So again, we're going to use density as a conversion factor, okay? So I'm going to start off with 325 grams. Now my density is 0.850 grams per milliliter. So what volume am I going to have to clean up? Well, here I'm going to put 1 milliliter on top and 0.850 grams on bottom. So grams will cancel. And I will be left with 3.82 times 10 to the second milliliters, or 382 milliliters. Okay? So density as a conversion factor. Okay, so now here's a similar problem to what I did when we bought our camping trailer, where I calculated out the mass of water that would be contained in the tanks. So you have a fish tank. You're trying to figure out, should you fill this fish tank outside, set it down, get your hose, fill the fish tank up first, and then pick it up and carry it to its location? Or should you put the fish tank in its final resting location and then figure out how to fill it with water? So let's see here. Could you conceivably lift this fish tank if you filled it first, based on how much that water would weigh? Okay, so we're going to do a multi-step conversion here. We are going to go from gallons to pounds. We have a lot of steps that we have to do this. We're going to go from gallons to quarts to milliliters to grams to pounds. Now, why would I go through those particular steps? Well, if you go back in your lecture slides, there is a slide that I had that had a whole bunch of conversion factors on it. One column had US conversions, one column had metric conversions, and then the other column had metric US conversions. These conversions are all found on that sheet. So when you have something like that in front of you, that's a good stepping point to figure out what progression you need to do. Under no circumstances should you Google what the conversion factors for any of these random things are, because when you go to take your test, all right, you're taking your test in person. You are not going to have Google in front of you. Utilize that slide that I gave you with conversion factors on it. I use that slide when I write your test questions. So make sure you know how to use the conversions on that particular slide. Okay? All right. So we have to go through a whole bunch of steps here. How do I do this? Well, I'm going to start off with my gallons of water. I have 30 gallons. Okay? Gallons to quarts. So when I look at that conversion page, I have 4 quarts per 1 gallon. I have 946.4 . milliliters in 1 quart. All right, now to do the milliliters to grams conversion, that's where I use my density. My density lets me convert between volume and mass or mass and volume. Okay? So even though it's 1, I still have to show it because when we do conversions, it's not enough just to convert the numbers. We also have to convert the units. And so it's very important that we show the conversion of everything. Okay? So I have 1.0 grams for every 1 milliliter. And then I have 1 pound in every 453.6 grams. Okay? So when I run the numbers, I'm going to get 250 pounds. So in addition to whatever the tank itself weighs, because remember the tank's going to have some weight to it with all the glass and metal on it, in addition to whatever the tank itself weighs, the water alone would weigh 250 pounds. So is that something you're going to be able to fill and then carry to its final place, or should you probably get it situated and then fill it? Probably get it situated. Now, when you have a long conversion like this and you are trying to figure out, oh my goodness, how do I run this on my calculator? Okay, what you can do on your calculator is you can do all the things on the top divided by all the things on the bottom. So into my calculator, I can type in 30 times 4 times 946.4, okay? And then I can do divided by 1 times 1 times 1, so I don't need to put that in, times divided by the 453.6. Okay, so that's a really easy way to do these on your calculator, is you can just do the top divided by the bottom. Make sure you put those parentheses there, though. Otherwise, your calculator will read it wrong. Okay? All right, so density.